So this is the first problem of today's Div2 contest, and in this problem we're given that Nini invented a new game based on an increasing sequence of integers a1 to ak. And in this game, initially n players are lined up in a row, and in each of the rounds of this game, the following happens. So Nini finds the aith, like a1, a2, and like and ak plays in a row, then they are kicked out of the game simultaneously. So if the ith player is in a row is kicked out, like if the ith player in a row should be kicked out, but there are less than I players right now, then like it's just simply skipped. So once there is like no one in a round is skipped, in that case, like the game ends and all the remaining players are declared winners. So I'll explain this example. So finally, what we have to do is we just need to find, like Nini has not yet decided how many people would join the game initially, and Nini gives us like q integers n1 to nq, and we should answer the following questions for each I from 1 to q independently. That is, how many people would be declared as winners if there are ni players in the game initially. So in input, we are given the first as the number of test cases. Then we have k and q, that is the length of the sequence of A, the number of values, ni, we should solve this problem for, like the length of the sequence A and the number of values that we should solve this problem for. So then the second line is k integers a1 to ak, and the third line is q integers n1 to nq. So we need to print q integers, like for each of these q values, we need to solve this problem, right? So first of all, tell me how many people were not able to understand the problem statement. Like, what is the problem statement asking? Okay. Like, you can raise your hands. See, first of all, like, let's try to understand what the game means. So let's take the example that is given to us in the input. So let's say we have this A is, and there are 5 players. So the players are 1, 2, 3, 4, and 5. These are the players that are lined up. 3, 5 means that you can consider that in each round, the players that are going to be removed are third and fifth. So third and fifth players are removed. Then we are left with 1, 2, and 4. Next, again, third and fifth player will be removed. But now we don't have any fifth player, so only this third player will be removed. Like the fourth player is now is at the third position. So this is removed. Now we have 1, 2. Again, third and fifth player will be removed. But the thing is, there is no more any third player or fifth player. So since in this round, none of the players are getting removed, both of these players are declared winners. So how many winners are there? There are 2 winners. So first of all, is everyone understanding how this game is like being played? Is it clear now? Okay, so now what we are given for each test case, we are given 2 integers k and q. K is the length of sequence A, and q is like for all the values, or we are given q different values of number of players, and for each of those q values we have to find that how many players will be declared as winners. Is the problem statement clear now? Then we'll come after how to solve this. So we are given k integers, that a is of size k, size k, a1, and basically this is true, first player, fifth player, seventh player, like this all the way up till ak. And we are given another array, or you can say that we have to answer for q queries, and in each query we are given a value of n, how many players will be participating, and in each round this is the number of players that will be removed. So now the problem is very simple. How? When are the people being declared as winners? The people are being declared as winners. Let's say these are the people, and we have to remove this, and this. In each round, these will be removed. So no matter, forget about these. As long as there are players which are more than this two, this is the first player which will be removed in each round. The second player will always be removed. In my above example, I had 3 and 5. So the third player will always be removed. So in this, second player is always being removed. So as long as there are more than 2 players, someone will be removed. So once we have less than 2 players left, we'll have a winner. Is it making sense? We'll have a winner that will be declared. Is it making sense? Yes, no?
Hello.
Yes, yes.
Can you take any test case and then,
Yes, I'll take an example.
for example, third test case?
Okay, third test case. So let me take the third test case. So this is the third test case. In this, we have NS5, not NS5, KS5, and NS QS4. Then we have third, fourth, fifth, sixth, and seventh players will be removed. All right. And we have to first solve for when there is just one player. So if there is just one player and you are removing, forget about these values, you are removing the third. So tell me one thing, if the third person will be removed, third player will be removed, you cannot remove this from just one player. So the answer for this is 1. Now you have to solve for 2. For 2, you cannot remove the third player. So answer is 2. For 3, you can remove the third player. And as long as there are more than 3 players, more than 2 players, you'll be removing them. So 2. And when you have 4 players, you forget about these values. As long as there are more than or equals to 3 players, someone will be getting removed. So the answer is 2. So what I have done, my answer is always minimum of this minimum, that is a of 0, or whatever the value is. Right now, ni, let's say ni minus 1. This is my answer. Is it making sense? Why? Not, I have written this only a0 minus 1 or ni. Basically, I cannot have more than these winners because these are the number of players. And as long as there are more than or equals to a0 players, one player will be getting removed. So that's why my answer is minimum of these. Is it making sense? Yes, no? I think I have already given a lot of time to this first problem because I also believe that the problem statement is a little bit confusing. But is it clear now?
Yes.
There are no doubts. And basically why we are just looking at A0? Like, can this not happen? Let's say there was so many players. I remove this, like there are, let's say, many players getting removed. So can this not happen that the remaining players will be less than, like, this is the third player. So can this not happen that the remaining players are now less than two? Like, let me take a better example. Let's say I'm removing many players from here. So can this not happen that the remaining players finally are less than whatever this is, A0 minus 1? Can this not happen? Like the remaining players are less than this. Can we always guarantee this? Like you get the question that I'm asking, right? There are many players, let's say 100, and we removed, let's say, like many 70 players. So is it always guaranteed that the remaining players will always be more than 30? Yes, it's guaranteed, right? Even if you removed every player from here, at least these players are left. Like even if you removed each and every player after this point, like let's say A0 was 7, and you're removing all players like 7, 8, 9, 10, all the way up till 100, then also you'll have the first 6 players left. So that's why the answer is minimum of A of 0 minus 1, or like whatever the value ni is. Is it making sense? Like hopefully this makes sense. So the implementation is simply this, that for each test case, I have first taken like the first value. This is A0. This is only that what I need. And I am simply taking all the values in Y, and I'm not storing them anywhere. These X and Y are basically like they are declared out of in this outside this. I'm not declaring. I'm not declaring them inside. I have declared int X, int Y before this statement, int X, int Y, int T. So what I have done, I have taken A0, and all the rest values are just taken input. I'm not storing them because they're of no use. Then for each of the queries, I'm taking this is my n. I'm taking it as input, and I'm printing minimum of X minus 1 or Y. And this is just a new line. Is it clear? Yes, no? Okay, so let's go to the next problem. So in this problem, we are given that you and Nini are playing a card game. The deck has 2n cards, and each card has an integer between 1 and n. Now, each of the integers 1 through n appears exactly on 2 cards. Additionally, there is a table where cards are placed during the game, and initially the table is empty. So now in the beginning of the game, these 2n cards are distributed, and you start with the first move. Like you'll put out your one of your cards, and the other person, that is Nini, will be able to say it. And then Nini will pick one card and put it on the table, and you, like, each of the players get 1 point if the card that they have chosen on the, like, to put on the table, the number on that card is is same as one of the cards that is already on the table. So I'll explain this here. See, the game is that initially there are 2n cards. Let's say n is 3. So there are 2n cards, and there are 2 cards with 1, 2 cards with 2, 2 cards with 3. Okay. Then there's a random distribution between cards. Let's say you get 1, 1, and 3. So what will Nini get? Nini will get 2, 2, and 3. So initially there is nothing on the table. You decide that you'll put 1 here. Now Nini sees this, and Nini will put 3 here. Now if you choose to put 3 in your second move, you'll get 1 point. Why? Because 3 is already on the table. Then Nini chooses to put, let's say, some other card. What? 2. like 2 was not earlier there, so Nini decided to put 2. Then you put 1. You'll again get 1 point. Why? Because 1 is already on the table. So this way you got 2 points, and in last move, Nini will put this card 2 in the table, and she'll also get 1 more point because 2 is already on the table. So Nini gets 1 point, you get 2 points. So first of all, is this clear how the game is being played? Then I'll explain what is being asked in the problem. Is this clear how we are getting points and how the game is being played? Okay, not clear. See, there are initially 2 N cards. You can distribute these into N2 sets. The first N cards are having 1, 2, all the way up till N. And this set is also having 1 to N. These are total 2 N cards. Then these cards are distributed between you and Nini. And initially the table is having nothing. Then you pick one card. Like the game is being started. Like the first move is made by you, and you pick one card and you put it on the table. And now both Nini and you can see like what is the card number. Then Nini picks one card and puts it on the table. If the table is already having the card with that number, the player gets 1 point. Is it clear? Okay, it's clear now. Like the game, like how the game is being played is clear to everyone, right? Yes, no? Or is someone still having some confusion? Okay, so now what is being asked to us? Now, since we are making the first move, and Nini's priority is first move is being done by us. I'll come to that part in a moment. All cards are shuffled. Basically, the distribution is already done and we know what cards we have. So like we know like what is the number of cards that we have. We might have 1, 1, 3, and 5. These are the cards that we might have. So we know the number of the cards. Like we know the cards and we know the numbers that are on them. So Nini's priority is first to maximize her score, and her second priority is to minimize our score. So now the problem that has given to us, what is the maximum score that we can achieve? So first of all, tell me, let's say we both had, you had 1 to N and you are playing against Nini and she also had 1 to N. What will you do? What is the first card that you'll choose? It doesn't matter because all are like from 1 to N. You can choose any card. Let's say you chose 3. What should be the card that Nini chooses? What should be the card? 3. Perfect. Why? Because she'll get +1. And if she chooses any other thing, let's say she chose 4, then it's better for you. Why? Because now you'll choose 4 and you will get 1 point. But her priority is to maximize her points and minimize yours, right? Maximize her score and minimize your score. So she'll choose 3. So whatever you will choose, she'll choose the exact same thing. So her score finally would be N and your score will be 0. So this is for those cases when you had all the cards from 1 to N and she also has all the cards numbered from 1 to N. But the thing is, since we are given that, like this is not always true, right? We might be having 1, 1, 2, 2, 3, 4, and she'll have something like 3, 4, 5, 5, 6, 6. So now tell me what card you will be choosing. Like if you choose 3, she'll choose 3. So she gets this point. And eventually you'll have to choose 3 for some, like after some time. And for 4 also. So you cannot get points for these, but you can always get points from these. Like these will never yield any points to you, but from these you can get a point, because if you put 1 on the table, she doesn't have another 1, right? So she'll put something that is like, maybe it's on the table, maybe it's not on the table. It is not our concern. But the thing is, she cannot get another 1. You'll put another 1 on the table in next move. So from these 2 1s, you'll get 1 point. And from these 2 2s, you'll get another point. But you can never get points from this 3 and this 4. Why? Because she is not dumb enough. Like, since you are making the first move, she will never put out this 3 before you. See, first you'll have to make a move and then she has to make a move, right? So why will she ever put her 3 before your 3? She has equal number of cards, right? If you put this one out, she knows that you have the other one also with you. So she'll put something that she has of 2. So she'll put 5. Then you put another 2, she'll put 6. You put another 1, she'll put 5. You put 2, she'll put 6. Once you put 4, then she'll put her 4. Once you put out your 3, she'll put her 3 on the table. She'll never put her 3 or 4 before you. Is it making sense? Like, this is the optimal way to get the maximum number of points for her, right? And minimize your number of points. So you can never get points for these which you're having, like for which the frequency is 1 on your side, and you'll always get 1 point for the 2 cards that you have in pair. So you just need to count how many pairs of cards you have that are having the same number. And your answer is like, let's say you had 2, 2, 4, 4, 7, 7. So your answer is 3. Is it making sense? Yes, no? What about others? Is it clear? Okay, so let's look at the implementation. Like, if anyone is having any doubt, you can ask me. Like, you shouldn't, like, if you are thinking like, okay, everybody is saying yes, so if I ask my doubt right now, like, it would be unnecessarily prolonging this session. Don't worry about it. I like right now, like, see, after 1 month, I would be like, I would be in that state that I'll be only looking at the questions that I think that are smart. Like, don't get me wrong, but yes, after some point, I won't be picking each and every question. Like, if you ask me some generic doubt, like why I have used like anything like that you might consider silly, that why I have used a do while loop and not a while loop. So after some point, I won't be picking these kinds of questions. Why? Because see, we have already covered all of these things, and we are at a position that like we all like you have to improve, right? So we cannot get like, you can ask me those questions, but after the session, not during the session. But right now, since the batch has just started, I don't think like I will like skip any question right now. So if you have any questions, you can ask me. Okay, so let's go to the implementation. So this is the implementation. In this, I have just used a count map, and okay, please don't denote. Like, I don't know how, like, why do I have to tell this in each and every session? Whoever have done this, please remove this. I have disabled the annotation, but like, you need to remove this. I cannot start that, like, remove this. Like, the game is always like, you will always start the game. So you are playing against Nini and you are always starting the game. So it always gives the upper hand to Nini. Why? Because she is 1 move behind you. So she always sees which card you are picking. If you pick a card that she has, she'll also pick that card. Otherwise, if you pick some card that you have a pair, she also will have some pair. So she'll use that. So that's why she'll never give you a card which you both have. Like, let's say you have 2, she has a 2. So she'll never put it before you because she always sees your move. Is it making sense? Okay, and who has done this? Please remove this. Okay, where was I? Like, I don't know, like, like it gets on my nerve to see like why you have to experiment during a session. Like, what is the need of like trying out new things? So anyway, I have taken n as input, and this is my count. Like, I'm using a map to get the frequency of each and every element. So first, I'm taking the input and I'm calculating its frequency. Finally, I have initialized my answer as 0. I'm iterating through my count map, and if the frequency is more than 1, like these are the card numbers that we have. So if any card we have, like any like number is occurring twice, or like I'm increasing my answer by 1, finally I can print my answer. Is it clear? Yes, no? What about others? Okay, so let's go to the third problem. So this is the third problem, and in this problem we're given that there is a n cross n matrix. Initially it's filled with zeros. Now the jth element of the ith row of the matrix is denoted as aij. Okay, is this key value syntax to map? Yes. Whatever, like this is keys value, and I think this is supported. Like, you can check this once. Like, I think it was supported from C++, I think 13 or 15 something, so like 70 maybe. But otherwise, like, you have to use a iterator, like the usual way how we iterate through any iterable, not just map. But yes, this can also, like, I think this is like this goes pretty back, but there are like we can iterate over a vector also in this way for auto e of v, vector v. So yep, this is like this is the key and this is the value corresponding to that key. Okay, going back to this. No, don't worry. Like, these, like, it's like good. Like, you can ask these syntax. Like, if you don't know some syntax, you can ask me right now. Like, like like this is what I was talking initially. It's not like when you're in this session, like initially your target shouldn't be just to learn how to solve this problem. You can pick up new approaches or maybe new syntax, things like that. You can, like, that will eventually help you in the longer run. And this is like very frequently used. Like, once you get a hang of this, you'll never use iterators to iterate over a map. Like, why? Like, it's just messy and long, right, to write, to iterate over a map like that. So getting back to this, we have that there is this n cross n matrix initially filled with zeros, and the jth element of the ith row in this matrix is denoted as aij. So this is how we usually denote elements in a matrix. So now Nini can perform two kinds of operations. Type 1 operation is choosing an integer I from 1 to n. This I is nothing but the row, and then assigning this row all the elements of our permutation. And type 2 operation is choosing an integer I from 1 to n, and this I is now the column. And in this column, we'll assign the elements from our permutation. And finally, we need to maximize the sum of all the elements in this matrix. So the maximum number of operations allowed 2n, and we need to find the operations order maximum sum, like along with the maximum sum. So let me explain. See, we are given something like initially we have 0, 0, 0. Let's say we had 5 cross 5 matrix. So we have something like this, and we need to maximize. If I choose this as my, like, let's say my first type, third row operation, and let's say my permutation was 1, 2, 3, 4, 5. So this is what I'll get. Let's say I choose my 2, 4 as my operation. So it's second type, fourth column. So, and my permutation is 1, 2, 3, 4, 5. So I'll overwrite this as 1, 2, 3, 4, 5. So this way I can do at max 2n operations, and I need to maximize the sum. Is the problem statement clear? Like what is being asked? Like how are the operations being done? And what is that we have to answer? Like what
So,
is, yes.
like for each operation, can the permutation be different, sir?
Yes, permutation can be different for each operation. Like I have taken 1, 2, 3, 4, 5. For the second operation, I can take the permutation to be 5, 4, 3, 2, 1. So then I'll get 5, 4, 3, 2, 1 here.
Okay.
Okay, is the problem now clear to everyone? Okay, so now this is just a constructive problem. Like how can you get this? Like this has no like algorithm being used, nothing. Like how can you get the maximum? See, one way is I get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like first fill all the rows
Sir,
like this. Yes.
sorry to interrupt, but in the second example case, second test case that they have given,
Yes.
so can't we fill all twos in it, sir? Like,
Okay. In the second,
yeah,
can we
in
not?
the yeah,
Yes.
in the last case also we can take a permutation as 2 1 and fill it from the first row, right?
Okay. See, in that we have something like this 0, 0, 0, 0. And you are saying that can we not do something like first 1, 2, then 1, 2, and then what?
2 1, we can take a permutation as 2 1 and fill the first column.
Okay. And
Then we can take a permutation 2 1 and fill the last row.
2, 1, like first take 2, 1 and fill the last row. Okay. Yes. And then
Okay. Okay, it's been overlapping, right? Sorry, sir. Yeah, I got it.
yes, like basically, I think you thought that we would be able to make each and every two, right? Like
Yeah,
some
yeah, yeah.
you would have chosen like 2 here and 1 here. But if you do 2, 1, like then you'll be overriding this as 1 and
Yeah,
this
yeah, yeah, yeah.
will
For
have this
it's
one.
been overlapping. Yes. Thank you.
Like eventually you cannot, like there will be at least 1 in your complete matrix. You cannot skip it. Why? Because whatever you like, you are using a permutation, eventually you'll be overwriting 1, right? You'll have like in your complete matrix, you'll have at least 1 1. Like this is the perfect example to see it, right? If you
Yes, sir.
had this doubt and now you're not having this doubt, it means that you have understood that you'll have at least one place which is having 1. So now let's say I was just giving an example. What we can do, we can first fill all the columns like this, and then what we can do, we can see that okay, if I replace this with 1 to n, I'll get a bigger value. So I'll replace this with 1 to n. Then we have 2 times 5 as the sum of this column. And what if I replace with this 1 plus 2 plus 3 plus 4 plus 5? So this is better. So I'll replace this also with this 1, 2, 3, 4, 5. And then again for this we can check, but I think it won't matter. So 6, 6. Yes. So this is, but this is not optimal. Why it's not optimal? Because in this, okay, is my voice breaking for everyone or is it breaking for some? Okay, voice is not breaking. Okay, audio is clear. Let me know in case like maybe if it's breaking for just one, well, maybe like the internet issues is on your side. But if like if majority, if like let's say for 5 or 7 people my voice starts to break, do let me know. Like I'll stop the recording. So getting back to this is also not optimal, because in this you can see that we have 5 at 5 places, 4 at 5 places, 3 at more, like 5 is at 7 places, not just 5. 4 is also at 7 places. 3 is also at 7 places. 2 is at 2 places and 1 is at 1 place. What is better? Like what is another better way? What we can do? We can first fill the last row, last column, or let's say, let's draw a matrix. So we can first fill the last column 1, 2, 3, 4, 5. Then we can fill this 1, 2, 3, 4, 5. Then we can fill this 1, 2, 3, 4, 5. Then fill this 1, 2, 3, 4, 5. Then fill this 1, 2, 3, 4, 5. Fill this, no, not this, this 1, 2, 3, 4, 5. Then fill this 1, 2, 3, 4, 5. And fill this 1, 2, 3, 4, 5. Then fill this 1, 2, 3, 4, and 5. And then fill this column 1, 2, 3, 4, 5. Now you can see 5 is occurring the maximum number of times in this. Like 5 cannot occur more than these. 4 cannot occur more than these times. Like, because then you would be overriding some bigger value. 3 cannot occur, like this is now left. 3 is occurring these many number of times. 2 is occurring these many number of times, and 1 is occurring here. It should occur at least once. So this is the maximum sum. This is where is the maximum sum that you can get. And you get the approach, right? First operation, second operation, third operation, fourth operation. Like, let me number these. First operation, second operation, third operation, fourth operation, fifth operation, sixth operation, seventh operation, eighth operation, ninth operation, and 10th operation. Like when I'm saying 10th operation, it goes to the complete column. Is it clear? So this is like, and how did I come up with this? I also came up with this. Like first I tried to fill it like this. Then I tried to minimize the number of ones and maximize the number of fives, then fours, then threes, then twos, and finally one. So I tried to give this, and first I drew this, and then like I thought how I can come up with this kind of, like how can I get this matrix from these operations, and finally I got this pattern: first, second, third, fourth, fifth, sixth. So this is how you solve constructive problems. First, like find what you want, and then try to come up like how you can get it. Is that making sense? Yes, no? And you cannot get more sum than this. This is the maximum. If somehow you like drew this thing wrong, like you got something else, like you are thinking like some other matrix is the maximum sum possible, then your answer will also be incorrect. Like you're trying to get that matrix, like you're trying to construct that kind of matrix. So that's why. Okay, so let's look at the implementation. So this is the implementation. And in this, I have first taken n as input. Like this is the sum, like ith number will be coming 2i minus 1 times. You can see here, like how many times is 5 coming? It is coming 9 times. 2 times 5 minus 1. 2 times 5 minus 1. 9 times. 9, 5, 45. How many times 4 is coming? 4 will be coming. 2 times 4 minus 1. 7 times. How many times 3 is coming? 2 times 3 minus 1. Basically this. This is 2 times 3 minus 1, 5 times. How many times 1 is coming? 2 times 1 minus 1. So just once. So this is my total sum from 1 to n. I'm printing my answer and the number of operations that I need. Then I'm going from n to 1. I am coloring the last row, then the last column. Like not coloring, I'm like initializing those values, last row, last column. So these are my operations. And this is just the permutation from 1 to n. This is also just the permutation from 1 to n. So last row, last column, second last row, second last column, this way. Is it clear? Yes, no. What about others? Like solving these problems is, yes, it comes from, like if you have solved these kinds of problems earlier, constructive, it helps. Yes, of course. Like otherwise, like first of all, like coming to that matrix, like first of all, you should have like what you're targeting. Like for constructive problem, you should have that matrix in mind. You cannot say that, okay, I'll just come up with the approach of getting the best matrix. First, you should have like what you are constructing, and then you'll like how to construct that. Like if you don't know that this is what you're looking for, this thing, like you'll probably end up writing something wrong. And if you somehow like started with like wrong metrics, then your construction will of course be wrong. So that's that. Yes, you are using all the operations, 2n operations. Maybe there is some other way to construct the same thing with lesser number of operations, but since we had 2n operations, I used all. So going to the next problem. So in this problem, we are given that Nini gave you an array of integers a1 to an of length n, and we can perform the following operations no more than 5 into 10 to the power 5 times. Choose two integers L and R such that L and R are both between 1 and n. Compute the max and simultaneously set all the values from L to R equals to x. Now max of integers is nothing but the smallest non-negative integer m, which does not occur in set C. Our goal is to maximize the sum of elements of the array A. So find the maximum sum and construct a sequence of operations that achieves this sum. And we don't have to minimize the number of operations. We just need to make sure that the number of operations don't exceed 5 into 10 to the power 5. The most important thing in this problem statement is that the number n is less than or equals to 18. That is the length of this array. And then this is okay that the elements are between 0 or 10 to the power 7 inclusive. And in output, we first need to print the maximum sum, then the number of operations, and then all the operations one by one. So first of all, no more than 5 into 10 to the power 5 operations. If you choose each and every subarray of this array, like the size is at max 18, right? There are at max 18 elements. And first of all, let me explain the problem statement. You're choosing a subarray L2R. You're calculating its max. What does the max? Max is basically the maximum, not maximum, minimum positive, or I should say it's non-negative. Minimum non-negative integer which is not part of the set, which is not included in the set. Included in this set. All right. So from L to R, like let's say these are the numbers 1, 2, 3, 4, 5. For these 5 numbers, we need to find the minimum non-negative integer which is not included in this, right? And non-negative is different than positive. Non-negative integers are 0, 1 all the way up till infinity, and positive integers start from 1 all the way up till infinity. So these are positive, these are non-negative. This is the difference. So now, how many different ways are there to select the subarray for this? There is basically 1 plus 2 plus all the way up till 18. So there is 18 into 18 plus 1 by 2. So at max, like you'll have operations, like you cannot have more than, like there is no way you are choosing more than 5 into 10 to the power 5 operations. Is it making sense? Because there are like not those many subarrays. How did I come up with this? This is nothing but, if you start here, this is your first is your starting point, your closing, like you can choose your R to be, like for R you have 18 options. If this is your L, your R is having 18 options. For this, your R is having 17 options. For this, like this to be a start point, L, your R is having 16 options. So all the way till for last, your R is having just one option, this only. So L is this, R is also this, one option. So just sum of 1 from 1 to 18. And what is the sum of 1 plus 2 all the way up till n? This is a arithmetic progression. The sum is n into n plus 1 by 2. Okay. So this is how I have computed this, if someone like was confused. So 5 into 10 to the power 5 is just a number that tells us that we can have as many operations as we want. Now, how to solve this? Now, first of all, is the problem statement clear? Is the problem statement clear? Yes, no? Yes, we'll brute force. Like n equals to 18 tells us that we can brute force. Of course, we'll brute force. Is anyone having any doubts in the problem statement? Yes, no? If you have, you can ask me. Okay, so in this, one thing is n is between this. So this is very important. This tells us that we can brute force. Now, what do you think? How we should brute force? See, let's say we need to find our answer from first place to the last place. Like, what is the answer for the complete array? Now, how we can break this? Like, we need to maximize the sum, right? So, how will we, how can we find the answer? Yes, L2 are consecutive elements. Like, what do you mean by consecutive elements?
Like 1 and 2 or 2 and 3.
Yes. Okay. Yeah, I got the idea. You are right. Like, anyone else? Okay, see, we need to find answer from, like, let's say from L to R. So first of all, we'll see what is the sum from L to R. Like, if we're trying to get something better, like we are trying to get the sum more from L to R, first we should know what is the sum from L to R. So then once we know what is, let me write this. So there is an array and we are trying to get, let's say we are trying to get the maximum sum between L and R. Forget about the rest of the array. We are not worried about this part and whatever is beyond this part. So we are only focusing on this thing. Currently, we are trying to get the maximum sum that is possible between L and R. So one thing that we need is sum of elements from L to R. Why? Because this is what we are trying to maximize, right? The second thing is we need the max of this, right? And we need the maximum of the max of this, and we need what is the point at which this max appears. We need max and position of max. Why we need position of max? Can anyone tell me? Like, not position of max, basically, like max is basically not occurring in this. We need the maximum, like the maximum element, not max, but max. Like we need MEX and MAX, position of max element. Why do we need this? I'll tell in a moment. And we also need what is the maximum element. Why do we need these? Because if my maximum element is, let's say it's not at the first place, then what will happen? If my maximum element, like there are two cases, three cases. My maximum element is at first place, last place, or is in between. And if my maximum element, let's say my max is 3 and my max is 5. So if I remove 5 from last place, from this place 5, the max of this thing will remain same. Same thing if my 5 was occurring here at the last place. But if this is not true, then my max can change. Like for this place, my max will change. If let's say my max was 3 here and I was getting 2 only here. So then my max will change. Max is basically the minimum non-negative integer that is not included in the set. Like I think I should not use different names for max and max, because then it will confuse you more. Like if I rename them, like max means maximum of a set, and MEX, max means that minimum non-included, non-negative integer in the set. Minimum non-negative excluded integer from the set. So like I said, we just need these things. And if like I'm able to get that my sum here, like if my sum can be increased, I'll try to get this sum to a bigger value. So how to do that? Just see that, let's say, like when do we need to do an operation? Let's say we are doing we need to maximize the sum between L and R. So first we'll check if L is equals to R. If L is equals to R, then what? Can someone tell me? If L is equals to R, then what will you do? If you perform an operation from L, like only single element, and that element is not 0, what will it become? What will be the max of it? First of all, yes, it will be 0, and you are setting that element to 0. Otherwise, what will happen? You can just find the max from L to R, and you're initializing it, right? So that is exactly what we'll do. If we find that, okay, we can get the sum between L to R more than the sum right now, we'll just perform the operation, initialize the numbers. And what will be the numbers? Numbers like maximum in like max, MEX, not max. Max in this question. Can someone tell me what can be the maximum value of max? What can be the maximum value of max? 18. Can it be more than 18? It cannot be 18 plus 1. Can it be? It cannot be length plus 1. Why? Because in order to be, for length plus 1, in order for it to be 19, your element should be from 0, 1 all the way up to 18. You're having 19 elements, but you can have only 18 elements. So that's why if you can have only 18 elements, it should be from 0 to 17. And then like 0 to 17 inclusive, and then you'll have your max as 18. So that's why. Anyway, so this is how we'll perform recursion, that when we are solving from L to R, we'll ignore this part, try to get the maximum value from L to R, then break this array further down and calculate for this, what is the, like, this can be broken. If this is the array, this can be broken into like either this, or this. So get these also, try to get the maximum values of these also. And eventually, like I said, how to get the maximum value, you just need to see that what is the sum right now, and you need to compare it with, if you replace this thing with the max of it. Like, it's a simple recursive problem, nothing else. For each subarray, just compute, if you replace it with its max, like if you apply the operation here, what is the maximum sum that you can get for L to R? And while calculating it, just see that if you break this, calculate separately for these. Like, if you like, what is the maximum sum that you can get for this and maximum sum for you can get for this. When you're doing for this, check if you apply operation here or if you break this further down. Like, this will be clear when I show you the implementation. Like, the implementation, like, even though there are these functions, they're simple recursions. See, first of all, I've taken n as input, then I've taken the array a as input. This is my first function I'm calculating for 0 to n minus 1, my L to R, maximum value from L to R. So what is being done in this function? Just calculate the initial sum, check whether this is the length into length square. Why? This is the maximum that you can get, n as your max, right? For 18 size, you can get the 18 as the max. If the current sum is less than n into n, each element can, like, max mex can be maximum length, and it can occur at max this length number of times. So if you replace it with max, this is the maximum sum you can get. If this is less than this, call this function 2. I'll show what is happening in function 2 in a moment, but otherwise, just break this. How we are breaking it? Simply go to L position -1, like from L to R is shifted to position -1, or L is made to position +1. Now let's see what is being done in function 2. So function 2 is nothing but if L is R, like you said, if this is not 0 and you do an operation here, you'll be making the element 0. Otherwise, if you are doing from L to R, we are just doing it from L plus 1 to R. And when we return back, we are just checking if A of L was not equals to R minus L. This means that the element at this is not equals to the length -1. The length between L and R, right? -1, and the length between these two -1. And if this is not true, then just insert this L and R in this and make all these elements. Like, this is basically the operation that we are asked to do, and do the recursion again. The same recursion, like for the next element. So this is like simple recursion. Like, from here, we are just calling this function. And this function's purpose is to get the maximum sum from between L and R. And this recursively just calculates what is the sum right now, whether we can get the sum better. If not, break it. If we can get, call the another function, and it will just apply the operation. And while applying the operation, I have done the same thing that is being told in the problem statement. If L is equals to R, just my A of L will become 0 and I'll return. Otherwise, I'm doing like breaking it apart. I'm calculating it for the subarrays. Finally, once I return from this, I'm calculating the sum. I'm printing my sum, my operations, like how many operations. These are the operations from L to R, right? From L to R, I am applying an operation. I'm printing the operations one by one. So this is a recursive problem. So I know, like, if you haven't covered recursion right now, this would be going like completely over your head. But once recursion is covered, then probably like you can come back to this problem and solve it. And I think there would be another, like, other better ways to solve this. Like, recursion is one of the ways, but I think there are other ways also that you can solve this problem.
Sir, I have a doubt.
Yes, yes.
Uh, Suppose there is a condition that we can make, like where we have elements 0 to 17.
Okay.
Like there can be a possibility where we do the operation on some different individual elements and then combine them. How we can pick them? Like it's kind of a bit masking. I
Like,
was getting
can you give
stuck
me an
here
example?
actually. Like, as such, I
Oh,
don't
no,
have
no,
an
no.
example,
Okay, okay.
but
I
this
got
thing
it. I
can be
got it. You are
possible.
saying that we applied operation on this, then we apply operation on this, and then we complete, like, apply operation on combination of these, right? This is what you're
Yeah,
saying.
maybe we can have 0 to 17
No, no, no. This is
all
not
the
like,
elements.
see what you'll do. Maybe you had 0, 1, 2, 3 here. You applied operation on these and you got 4, 4, 4, 4. Here you had 0, 1, 2. You got 3, 3, 3. If you combine these, you'll get 0 again. So,
Means that situation cannot be created.
like, it won't be optimal. You can do it, but it won't be optimal. And you can say,
But we
like, okay,
want some maximum.
like you can have 1, 1, 1, 1 and 3, maybe 0, 0, 0. So in that case, you can say, like, okay, I first applied operation on this, then on this. So here I got zeros and here I got ones, and then on combination I got twos, right? You can say, like, this is like better, that first I applied operation on this, then on this, and then on combination of these. But why not apply operation on start by applying on this? Then also you would have got these. So that's why, like, this is like never more optimal.
Suppose we have three zeros, 0, 0, 0,
Okay.
and the element which is not present is 1. So we can do that operation on the second and third zero.
Yes, yes. Okay, yes. This, like, okay,
Then
okay.
we get 1.
You got this.
And then for this we have 2. Like suppose
Then
with the
you can
left
get it.
one,
But
with the
then you're
left
not
one,
applying operation on this. Like, you're not applying operation on this. Yes, this is
no, no,
this
no.
is
I'm
applicable.
saying like with the leftmost one, suppose there is more elements on its left side, and if we do that, it will be turned into 2, and for the uh,
Yes, yes, yes.
remaining
This
part
is
of the rest, it can be
this is valid.
created,
This
right?
is valid. Yes, this is valid. This
That's
way.
what I'm saying. Like if we have 0, 1, 2, 3, and up to 17 elements
Okay, okay, okay.
in a consecutive order,
Yes, then.
then can this be situation created? And this can be created if we do operations on individual elements and then combine them.
Like,
Suppose I get to this situation performing individual operations,
yes, yes.
and then
And
if
then
I
you can,
combine,
in combination, you can get
we
18
can get
everything.
18 n times.
Yes. But again, like, this is like, since there are only 18 elements, you cannot get this kind of situation by applying operation once. Like, how will you get just 2 here? How will you get just 17 here? If in order to get 17 here, you should have a combination of how many elements? At least
0 to
17 elements.
16. I
At
mean,
least
yeah,
17 elements. So there will be 17 17s. Or you're
yeah,
getting this already. You get my point?
yeah, yeah. Okay. Thank you.
Yes, yes. So that's it. And thanks for joining. Bye bye.